All right, I stopped guessing how many videos I'm going to make on 8.5. Might be quite a few. But all right, we have this problem. This is 8.5 video number 4. So when I said there were 3 videos, I guess this is number 4 of 3. No, it's going to be 4, and this might not even be the last one. All right, so this is a pretty long problem, I suppose, because first of all, the denominator isn't factored. So our job is to factor it. Once it's factored, our job is going to be to break it up into the individual factors, but we're not there yet. So I see something like this, and f of 1 just seems reasonable, like 1 might be a 0. I mean, we have methods that get a little more involved, but just try 1 and run it through here. 1, get -4, 3. All right, I got a 0. So that means this polynomial is going to factor with x minus 1, and this is the quotient, x squared minus 4x plus 3. Numbers that multiply will be -3 up to -4. And notice I get, well, if I put the x minus 3 first, I get x minus 3 and x minus 1 squared. So that's the denominator. So rewriting the original fraction, it was 16x squared over, now it's factored. So I'm going to take this first factor, x minus 3, and I'm only going to write it once because it's to the 1, x minus 1 and x minus 1 squared. And atop each of these, get a letter A, B, and C. I'm going to clear fractions by multiplying everything by x minus 3, x minus 1 squared. Everything gets multiplied by that to clear the fractions. 16x squared equals a times x minus 1 squared after the cancellation, b times x minus 3, x minus 1, and c times x minus 3. All right, I normally would set up the system of equations, but I just want you to know how convenient this, again, what I call the forbidden values is, because once you see it, it's really one of those things you want to do. So let me change to another color here and say, you know what? If x were 1, this would be 0, this would be 0, and this would just be c times -2, and this would just be 16. So I get c equals -8. Now I'm nowhere done, but wow, that is really, really nice. Because there was a value I could put in that created all those cancellations, it just gave me that value really quickly. Let's go back over this. With the other forbidden value, we only have 2 forbidden values here, and what's the other one? I already used 1. What if x were 3? So hopefully you see that, right? If x were 3, this would be 16 times 3 squared. This would be a times, well, 3 minus 1 is 2. 2 squared is 4. And this would be 0, and this would be 0. So I'm going to get 16 times 9 equals 4a. Let me just leave it that way and divide both sides by 4. I'll get a on this side, and I'll get 4 times 9, or 36 on this side. So a is and has always been 36. So we still need a method to find b. So I don't want you to think that we're completely done with this problem, but this forbidden values method has yet one more thing to teach us. So I'm going to go ahead and kind of extend something here. And I call it the forbidden values method because it's the forbidden values that give us the gold. They give us a number right away. They give us all these terms that drop out. They're great. But there's one more thing I haven't told you about this method, and that is, sure, it's going to give us some values, but how we can actually use it to find b, maybe. All right. Or a combination of things. Remember how I normally do this with a system of equations, and I don't want to do that. I don't want to multiply this out. I don't want to equate coefficients. I'm going to use a non-forbidden value, just a convenient value. So I guess we call this the convenient value method. I'm still looking at this. But what's a convenient value of x I can put in there just to make this feel a little bit nicer? All right. So I could say let x equal 1, but and that would give me something. I mean, the something would have a, b, and c in it. It will have all of the terms in it. But I already used 1. Sorry. I could use 1, I could use 2, or some number I haven't used. But the number I'm going to use is 0. What if x were 0? Well, this side, 16x, so I'm kind of done with this, so I'm going to erase it. What if x were 0? Well, this side would be 0. And this would be 0 minus 1 squared, that's just going to be 1. That's going to be a. And if I put in 0, this would be b times what? Negative 3 times negative 1, that's 3. So I'll write it as 3b. And if I put a 0 in here, I'd get minus 3c. Now hopefully you see what just happened. Instead of setting up a system of equations to find these lines, I also found a line by using not a forbidden value, but a convenient value of x. So in this one case, anyhow, it really paid off. I already know a, it is 36, and c is negative 8. So 36 plus 3b plus 24 really 60. All right, so what do I get? 3b equals negative 60. B equals negative 20. Let's see. B was, in fact, negative 20. So this problem could have been a lot longer if I made it longer. And what I mean by that, and I'll go back to an earlier problem, what I mean by that is, if I had, this isn't the same problem, but if I had gone through the coefficient work and done all of that, I could have gotten that. But instead, I took advantage of my shortcut by letting x equal something. So let me kind of review what I did. only got this one equation. The very equation you get by clearing fractions. And then systematically I let x equal, I think the first thing I did was let x equal 1. And that told me that c was equal to -8. Didn't do anything with that. That was great. All right. When I say I didn't do anything with that, I just said, all right, let's go pick another number. All right, so I let x equal 3, and that gave me a was 36. So in other words, these were final answers, or they felt like final answers. And then I said, well, let x equal 0. And I knew that wasn't just going to give me a final answer. I mean, I could have just said, let x equal 5, or let x equal 10. I knew it wasn't going to give me a final answer. It's just 0 is a very convenient number, because it's easy to work with. But what did that give me? Instead of giving me an answer, it gave me a whole equation. But I could take that equation and substitute my a and the c that I found earlier and solve for the only one that was missing, which was b. So this system really, this technique really can save some time, where you're picking your x values. And if you are looking for 3 letters, A, B, and C, you'll need to pick 3 x values if you're going to do this. The more forbidden values you have, or I should say, let me call them previously forbidden values that you have, the more times you're going to get the answer right away. But when you have 3 letters you're looking for and only 2 forbidden values, this method is going to work until you, and then you need to just pick your own number. All right. Now, let me go to the last topic. Well, that's actually it for our homework. But I'd be remiss if I didn't tell you about the cases that we're intentionally skipping. All right. So what if, instead of a problem factoring like they have been with linear terms like x minus 1, what if I had x squared plus 2? It could have more terms in it, but it's not the number of terms. It's the fact that x squared plus 2 doesn't factor. I think you know what's going to happen, at least part of this. The x minus 1 would be in the denominator, and the x squared plus 2 will be in the denominator. But what changes is, well, they used a and b here. I'm going to use a for the first one. Since I already used a, what am I going to put here? Well, it's not just going to be a single character like b. It's got to be something like this. Now, I've already used a, so the next letter in the alphabet, bx plus c. So if you have degree 2 down here, you're going to put degree 1, meaning, well, degree 1 plus degree 0. You're going to put this entire equation here, there. So to kind of match this up, if I had just x minus 1, that just gets a single letter. I'll put C up there. But if I have an entire thing that doesn't factor, I need all of this up there. All right, so this is if it's not repeated. What if it is repeated? Well, that's this last situation. Only, you can't even see it because it's off the screen, but let me get there. All right. There's a fourth case when you're factoring, and that is your denominator can have a repeated irreducible quadratic. So for our purposes, I've been using the example x minus 1 as a linear term and x squared plus 2 as a irreducible quadratic. I could factor this, but it would require complex numbers to factor it, and we're not doing that in this section, so this is considered irreducible. But what if you had a repeated irreducible quadratic? Let's say I had, doesn't even matter what I have in the top, so question mark, question mark, question mark on the top, but I had x minus 1 times x squared plus 2. And to make this a little more interesting, let's say this was squared and this was cubed. So if I had a repeated linear term and a repeated irreducible quadratic term, what would the setup even look like for this? I'm going to run out of space if I write it there. I might run out of space no matter where I write this one. I need an x minus 1. I need an x minus 1 squared. And on top of the linear terms, it's just a single character. I need an x squared plus 2, x squared plus 2 squared, and x squared plus 2 cubed. And the reason why I carried out to cubed is that was the highest degree of this. On top of each of these, until I run a letters of the alphabet, it's going to be cx plus d, ex plus f, what am I up to, gx plus h. I have to tell you, this is terrible. So, I mean, the work involved in this, in finding A, B, C, D, E, F, G, and H could be incredible. Notice the lack of forbidden values here. I'm looking for 1, 2, 3, 4, 5, 6, 7, 8 letters, and there's only one forbidden value, meaning the only value I could put in for x that would cause a parenthesis to equal 0 is 1. Irreducible quadratics generally don't have zeros you can put in. So you'd be stuck solving a system of equations, a huge system of equations, to do something like this, which is exactly why I'm not having us do it. But I do want you to be aware of it, and that is anytime you see a polynomial, let's just make something up. Let's say it had 6x cubed plus 2x plus 9. All right. When you see a polynomial or a rational expression like this, it's the answer to a question that looks like this. All right. Now, I've used this example once before. When you see, as a child, 783, that's the answer to the question 700 plus 80 plus 3. This is what decomposition is. It's taking something and writing it as a question where we're adding things with certain properties. I mean, this is also equal to 782 plus 1, but we're not looking for that property, at least not when you're doing this as a child. You're looking for the place values. Well, in this case, we're taking something like, well, we're not going to do it, but if you really go farther on in math, I'm talking like calculus 3 and beyond, they'll take something like this, and I mean, you might see this in a calculus class, but nothing this big in calculus 3, because calculus 2. You have to go beyond calculus to really see something like this, and some of you might. So I just want you to be aware of it. But back to this, when you're given something like this, it's the answer to a question that we can decompose using many of the things you've learned, like factoring and possibly solving systems of equations. So this really is a culmination of a lot of different little skills that coalesce into one kind of major skill. Now, one thing I haven't expressed here is you can always check your answer by adding them together. In other words, if I add this up, I should definitely get what I started with. This, by the way, was an example. I don't think I did in this section, in this video. I was just still on my screen. Oh, no, it was. That was the example I did in this video. Okay. So adding this, I should get that. If I got something different, well, that means something was wrong. But that's it. I think I did cover everything. So this will be the last video of the section. Section 8.5, partial fraction decomposition. And again, it's part of the systems of equations chapter because maybe you need systems of equations or maybe not to solve these. And I'll have to leave it at that. That's 8.5. I'll see you in another video, another section.